Today's video can be found on page 1 in your 3C packet, equation solving. This is in the 6th grade text, the pink series, 6th grade textbook. It's in the B book, volume B. It's chapter 8, section 1. This is page 5 if you want to follow along. So solving algebraic equations. You can use substitution to solve simple algebraic equations. The figure shows a balanced scale, and you can see the fulcrum here, so it's kind of like a teeter-totter. It's keeping it balanced. Find the value of x, which is right here, x, such that the left side balances out the right side. So one little box here you can see represents one counter, and x represents x counters. There are x plus 5 counters on the left. So this is x plus 5. There are 8 counters on the right. Since the two sides balance each other, they have to be equal. You can think of an equation as a balanced scale where the left side always is balanced by the right side. So the left side, or what's called the left member, this is called the member, the left member. So equations have members. This is the left member, then there's the equal sign, and here's the right member, or side of the equation. I'll say member and side equally. Since the two sides balance each other, x plus 5 equals 8. That is called the equation. To solve the equation, you need to find the value of x. Well, that makes x plus 5 equals 8 being true. So if we say, what if x was 1? Well, we know 1 plus 5 is 6, not 8. If we say x is 2, well, 2 plus 5 is 7, not 8. If x is 3, ding, 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 that equals 8. So the equation x plus 5 holds true only when x equals 3. X equals 3 gives the solution of the equation x plus 5 equals 8. So it's the solution. Next page. Solving algebraic equations involving addition or subtraction. So solve the equation x plus 6 equals 9. So here's a model of it. Here's my x plus 6 in the left member. Here's my 9 in the right member. The fulcrum's like the equal balance idea. So there's the balance scale. When you remove the 6 counters from the left side, so these are taken off, you get x plus 6 minus 6 is less than 9, right? X plus 6, we took those 6 away. So x is less than 9. To balance the scale, you would need to also remove 6 of the counters from the right side. So we got to take 6 off, right? So now I get that x plus 6 minus 6 equals 9 minus 6. So I've taken 6 away on the left member, 6 away on the right member. The book does it horizontally like this. I'm going to do it vertically. And you can see that x equals 3. So subtracting 6 from both sides, we've solved the equation to the solution is x equals 3. We can check that. Substitute the 3 back in for the value of x, and yes, we've known for a long time that 3 plus 6 equals 9. So getting you to see the idea of balancing an equation. That's what this is all about. The picture. Get the mental picture that goes along with this. So solve the equation 6 is equal to x minus 3. 6 equals what minus 3? I say what, meaning the x is what? I don't know. What minus 3? So if I add 3 to both sides, because it's a subtract equation, add 3 to both sides, I get that 9 is equal to that x. And I can check it by putting 9 back in for the x value. Yes, 9 take away 3 is 6. When x is 9, the equation 6 equals x minus 3 holds true. So that x equals 9 gives you the correct solution. You can also solve equations that have fractions in the exact same manner. Now the book again does it horizontally like this. we're not going to do it horizontally. So it's not going to look exactly like this. Solve the equation x plus 1/10. So what plus 1/10 will give you 3/10. Write your answer in simplest form. Decide which operation to use. Since 1/10 was added to the variable, you will need to subtract 1/10 from each side of the equation. So when we do it, we're going to do it vertically, not horizontally. So this is what it's going to look like. Subtract 1/10 from both sides of the equation. Both sides of the equation. We got to keep the balance. Remember, we got to keep the balance. So here's our fulcrum here. We're keeping this balance. So when we subtract 1/10 from both sides, I cancel them because opposites make 0. So x plus nothing. Well, we don't write x plus 0. Opposites do combine to make 0. What's called the additive inverse property is what I'm using here. Positive 1/10 and negative 1/10, when I add them together, I get 0. That's the additive inverse property. 3/10 take away 1/10 on the right side, or the right number, gives me 2/10. But it did say put it in simplest form. So yes, x equals 1/5 when we take a factor of 2 out of the numerator and denominator. And yes, that's what's shown here on the paper. Addition and subtraction equations. What is an equation? It's a mathematical sentence with an equal sign. We know that. Solve and check each equation. So here it's done vertically. So x plus 9 equals 43. We're going to do it vertically as shown here. Minusing 9, subtracting 9, because here's my goal. The goal of equation solving is to get the variable by itself. In fact, I do 4 steps for all equation solving, and you're going to hear me say this over and over again. First step, goal, find the variable. Oh, there's x right there. Step 2, inverse. Do the inverse operation so that you get the variable by itself. The goal is to get variables by themselves. They're loners. They don't like to be with anybody else. Make sure you keep the balance. Whatever you do to the left side, you do to the right side. Balance. Balance, key idea, that visual that I was trying to show you before. And the last but most important step, check your work. Make sure that solution that you think it is really the solution. So here's the goal. The goal, x. There it is, right there. What's happening? Adding 9. What's the inverse? Subtracting 9. Goal, inverse, balance. Do it on both sides of the equation, as you can see here. Minus 9, minus 9. Some people put a line down the equal sign like that to show that, oh, I subtracted 9 on the left and I subtracted 9 on the right. Then actually do the subtraction. Well, positive 9 and negative 9 cancel. Show the cancel step. And I get x is the only thing that's left on the left. Yay! X equals 43, take away 9, 34. Check. To check it, rewrite the problem. X plus 9 equals 43. Replace the x with what you think the solution is. 34. 34 plus 9. Take out a calculator. 34 plus 9. Oh, 43 equals 43. Yippee. I call it yippee. I make a little check mark at the end. Example 2. It's a subtraction equation. Here's x. What's happening? Subtracting 8. What am I going to do? The inverse. The inverse of subtracting 8 is adding 8. So I'm going to add 8 to both sides. Here's the balance step. Add 8 to both sides. Negative 8 and positive 8 cancel. So I get x equals negative 12 plus 8. Different sign, subtract. So 12 take away 8 is 4. Take the sign of the larger number, negative 4. Then you'll be exact. And the last thing we're going to do is check. So I rewrite the equation, the original problem. X minus 8 equals negative 12. Negative 4 minus 8 equals negative 12. Ooh, negative 4 plus negative 8, same signs, add and keep. 4 plus 8 is 12, and keep negative 12. Negative 12 equals negative 12. Yippee, I did the check. Example number 3. X minus 10 equals negative 13. Here's my x. It's being subtracted by 10. I'm going to add 10 to both sides of the equation. 10 to the left, 10 to the right. I get x alone on the left-hand side now. Negative 13 plus 10. Different sign, subtract. 13 take away 10 is 3. And I'm going to take the sign of the larger absolute value, which is the negative 13. So my answer is negative 3. Check. X minus 10 equals negative 13. Negative 3 minus 10, I'm replacing x with negative 3 equals negative 13. Negative 3 and negative 10, same signs, add and keep. Oh, that's negative 13, which equals negative 13 on the other side. Yippee! Got it right. Then you go on to the next equation. X plus negative 15. That's negative 15. Whoops. So I'm going to add 15, or positive 15. The opposite of negative 15 is positive 15. They cancel. And I get x equals 12 plus 15. 2 plus 5 is 7. 1 plus 1 is 2. 27. I'm going to check. Rewrite the equation. X minus 15 equals 12. What number take away 15 is 12? Well, I think it's 27. Take away 15 is 12. 27 take away 15? Yes, it is 12. Take out a calculator, make sure it works. Yippee! Next page. Then I'm going to change this middle problem here, so I'll get to that in just a second. Here's some rational addition and subtraction equations. Only addition and subtraction. Number 18 was a multiply, so I'm changing it. Number 15 here says Q take away 3/10 equals 7/10. So here's my variable, goal, inverse. The inverse of negative 3/10 is adding 3/10. So I'm going to add 3/10 to both sides. And these cancel each other. So I get Q equals 10/10. 10/10? Oh, that's 1. So Q equals 1. Check. I write the word check. Write the original equation. Q minus 3/10 equals 7/10. 1, and I'm going to put it back in as 10/10, which is 1. 10/10. Take away 3/10. Does that equal 7/10? Yes, it does. This is 7/10. Do the math. 7/10 equals 7/10. I'm going to be very picky about this process. Your papers need to look exactly like mine. There are no shortcuts, people. No shortcuts. X plus 5/14 equals 11/14. That's the problem that I'm changing here on number 18. It's an adding equation. The opposite of adding, here's my goal, x. It's adding, the opposite or inverse. Here's my inverse step. Goal, inverse, balance, check. Goal, inverse, balance, check. So the inverse step is to subtract 5/14. Both sides of the equation. That's my balance. My balance, keeping the balance. These cancel, and I get x equals 11/14. Why does this keep happening? Take away 5/14 is 6/14. I don't know what's happening with my smartboard there, but it's got to be in lowest terms. So 6/14, lowest terms. Sorry about that. I don't know why this volume thing keeps coming up here. It's 3/7. However, when I check, it's easier if I check with that 6/14 because that's got the common denominator. So x plus 5/14 equals 11/14. 6/14, not my lowest terms, 3/7, but my answer is 3/7. This is the answer, the solution. The solution is when the equation is true. So 6/14 plus 5/14, oh, that's 11/14 equals 11/14. So your check, the bottom of your check does not have your answer in it. Notice this 11/14 doesn't say 3/7. The bottom of the check is to say, oh, the right side is exactly like the left side when I substitute back in my answer, my real solution of 3/7, 6/14. And the last one here. here's my x, plus a half equals 1 3/4. So it's an adding equation. The inverse is to subtract 1/2. On both sides, balance. And this positive 1/2 and negative 1/2 cancel. So I get x on the left equals 1 3/4 minus 1/2. Well, can't subtract those. They don't have a common denominator. So I'm going to change my 1/2 into 2/4, because now I can do 3/4, take away 2/4, which is 1/4, and 1 take away nothing is 1. So I think the answer is x equals 1 1/4. So I'm going to put that back into my check. X plus 1/2 equals 1 3/4. I think the answer is 1 1/4 plus a half, which again is 2/4, right? So I'm going to put it in as 2/4 as a matter of fact. I'm going to change my 1/2 right away to 2/4 equals 1 3/4. So 1/4 plus 2/4 is 3/4. Bring along the whole number 1. Yep, 1 3/4 does equal 1 3/4. Yippee. And that's it for today's adding and subtracting video.